Welcome to the Ministry of AI, your go-to podcast for all things artificial intelligence. I'm your host, and today we're diving into an intriguing study that pits some of the biggest AI players against each other: ChatGPT, Codeium, and GitHub Copilot. These AI-driven programming assistants are all the rage, but how do they stack up against one another? Let's break it down. As AI tools become increasingly integrated into software development, they promise to revolutionize the way developers write, debug, and optimize code. This paper by Sultanul Islam Ovi and colleagues offers a deep dive into the comparative strengths and weaknesses of ChatGPT, Codeium, and GitHub Copilot. They tackled this by challenging each tool with 300 LeetCode problems, a favored battleground for competitive programmers. So, what's the big question here? Essentially, it's about understanding how well these tools can solve programming challenges of varying complexity. The researchers wanted to see not only how these AI companions handle easy and medium tasks, but also how they fare when the going gets tough. Let's talk about the methodology. The team selected a balanced set of problems, covering easy, medium, and hard difficulties across a spectrum of algorithmic topics. They meticulously configured each tool under consistent settings to ensure a fair trial across two phases: problem solving and debugging. This approach not only tested the raw problem-solving abilities, but also evaluated the tool's capacity to learn from their mistakes. The findings are rather enlightening. GitHub Copilot took the lead in solving easier problems, boasting a success rate of 97%. However, both Copilot and ChatGPT faltered on harder challenges, aligning with the human success rate of about 40%. Interestingly, ChatGPT shone slightly brighter in memory efficiency, particularly with medium problems, whereas Copilot was a bit faster in execution. But let's not overlook the importance of debugging. ChatGPT showed impressive self-correction skills, outperforming its peers by rectifying 42.5% of errors on hard problems. That's a nod to its learning and feedback adaptation capabilities, especially when the code isn't straightforward. Of course, every study has its limitations. The dataset, although diverse, doesn't cover all algorithmic territory, and the evolving nature of these AI tools means performance can vary over time. Yet, this study sets a solid foundation for continued exploration in optimizing AI-driven programming tools. So, what does this mean for AI and coding? Well, despite their prowess, none of these tools surpass human problem-solving and complexity just yet. Their real-world applications could be profound, ranging from accelerating development cycles to aiding education and training. But it remains crucial that developers acknowledge their limits and use them as complementary aids rather than replacements. That wraps up today's discussion on the Ministry of AI. Thanks for listening. If you found this valuable, please like and subscribe to our channel. To advance your AI knowledge further, check out our free courses at the Ministry of AI. You'll find the link in the description below. Until next time, outro music fades out.